So there are lots of ways that we can solve a system of equations. This being a system of two equations and two variables. But this time we're going to solve it using matrix operations. Okay, so the first thing that we want to do when using matrix operations is make a matrix. So if we take this matrix, this equation becomes the matrix 2, 1, 1, negative 3. Those are the coefficients. So that's the coefficient side of your matrix. And this one over here is going to be your solution side. Okay, and we separate them like this so that we can perform row operations on them and we can come up with a solution. So what we want, so this is what we're trying to do, this is our goal. Silly iPad. This is our goal, that's supposed to be an O. We want this matrix to look like this. We want the identity on this side, 1, 0, 0, 1. And over here, we're going to have your answers. So whenever we perform row operations on this thing, and we do some Gauss-Jordan elimination, this is what we want our matrix to end up looking like. This is going to be your X solution, and this is going to be your Y solution. Because remember, these are X coefficients here. These are X coefficients, and these ones are Y coefficients. It says Y equals, and this one says X equals. So that's what we're trying to get at, is we're trying to manipulate this thing right here. Trying to manipulate this so that we can do that. So let's make this and do some row operations on our matrix in order to get that answer. Okay? So the first thing that I'm going to do is actually, I'm going to swap these two rows. Okay, remember, I want to have a 1 in that top right, top left position, and this is a 1 already. So I'm just going to swap them up. Okay, so I'm going to put the bottom row on the top, which is perfectly legal, and the top row on the bottom. All I'm doing is just writing the equations in a different method. I'm putting the bottom one on top and the top one on bottom. Okay? There's nothing wrong with that. That is a perfectly good thing to do. It's even less work than possible. So now that I have that done, I need to make this number into a 0. So I want this to be a 0. So I'm going to use the elimination method that we use for solving systems. I'm going to multiply each of these values up here by negative 2. And then I'm going to add these two equations together. Okay, and that will effectively eliminate this x variable from our second equation. Okay, so let's see, this is going to be a negative 2, this is going to be positive 6, and this is going to be negative 26 when I multiply them all by negative 2. So now I'm going to add the first row plus the second row. Okay, so what happens here, the top row doesn't change at all. I can just divide all those by negative 2 again, and I'm going to get the same values that I started with. What happens on the bottom, negative 2 plus 2 is 0, 6 plus 1 is 7, negative 26 plus negative 2 is negative 28. So this is what my new matrix looks like after I performed that row operation. Okay, so I've got 0 right here, exactly where I want it, check. I've got a 1 right here, check. So the next thing I need to work on is this term right here on the diagonal. I want this one to be a 1. So if I divide all of my things by 7, both terms by 7, and that's perfectly okay to do. I can multiply and divide any row I want to. So I'm going to divide this row by 7, and I am going to come up with this new matrix. So remember, the top hasn't changed. I haven't done anything to it. So it stays 1, negative 3, and 13. But the bottom's going to become 0. 7 divided by 7 is 1. Negative 28 divided by 7 is negative 4. Okay, so from this term right here, I know that the y value of my equation, of my solution, is negative 4. There's 0 x's, there's 1 y, and the answer is negative 4. So now what I'm going to do is do some back substitution, because I want to make this number into a 0. Okay, 1, 0, 0, 1. So this number, this negative 3, has to be a 0. So what I'm going to do is multiply all of my bottom row by positive 3. Okay, multiply all these by positive 3. So positive 3 times all this row. Okay, that still makes this a 0, that makes this a positive 3, and that makes this a negative 12 now. So once again, I'm going to add it, the bottom row to the top row. The bottom row won't change. I'm using reverse elimination, I guess. And let's see what we get on the top. So 0 plus 1, starting on the left, 0 plus 1 is 1. 3 plus negative 3 is 0. Negative 12 plus 13 is 1. Okay, fantastic. So here on the left side, here I have my identity. This is exactly what I want, 1, 0, 0, 1. And here's my answer. My x value is positive 1, and my y value is negative 4. So the solution to this system of equations, way up here, the solution to this system is the coordinate point 1, negative 4. So we can check. Is 2 times 1 minus 4 negative 2? Sure is. Is 1 Maya plus 12 13? Yes, it is. Sorry. So this might seem a little long and arduous, and it is at first, but it is definitely one way to solve a system of equations by using matrix operations.